So the first thing that we need to do is draw a little hand. And then go ahead and label the angles. Alright, and then if we're going to use the hand trick, we need to write how we find the sine, how we find the cosine of an angle, and how we find the tangent. I'm hoping you guys already know this without me telling you. All right, what else do we need to know? The x. We do need to know the unit circle, so we can do that. We also need, like, the x is where we need to know the 3 middle fingers in the other quadrants. So let's do the unit circle first. So we have the angles, the quadrant angles. And don't forget, for 0 and pi over 2, if you want to do the hand trick, you can. But for 3 pi over 2 and pi, we cannot. Right, and then we have to write down how we find the sine, cosine, and tangent of an angle using the unit circle. All right, what do y'all think for the sine? Bless you. You're welcome. Y, cosine x, tangent y over x. All right, and then I'm going to draw some axes where we are going to write down the reference angle information. All right, and then the last thing we need is all students take calculus. It tells us where all the trig, the 3 original trig ratios are positive. that's it. So hopefully by next Tuesday, when we do our test, you guys will have all this in your brain and you just recreate it without me. But we'll keep on practicing it. All right, so today we are gonna do some more complicated trig equations. So these you might have to factor. You may have to use an identity. So it's gonna be a little more difficult to solve them today. But one thing that is great is they're all gonna be in an interval from 0 to 2 pi, so we aren't gonna have to do the plus n pi or plus 2 n pi stuff. All right, so this is lesson 5.3b. And we're still solving trig equations. Bless you. Okay, and like I said, for our examples, the directions are going to be find all solutions in the interval from 0 to 2 pi. All right, so our first one for A is cotangent of x cosecant squared of x equals 2 cotangent of x. Alright, so kind of like yesterday when we had, I think we had like cosecant on both sides. We wanted to get everything on one side, or get our cotangents, or get our trig functions all on one side. So let's go ahead and do that first. So we would subtract that 2 cotangent of x. So you guys think we can actually subtract these? No, they're not like terms. So if it was just cotangent of x minus 2 cotangent of x, definitely. But this cotangent is attached to that cosine squared, so we can't actually subtract them. And several of the equations we're going to solve today are going to need to be factored, and this one is one of those. So what could we do to factor this? Factor out cotangent of x. We're factoring out a common factor. Good job. Okay, and once we get it factored, then it's not too bad, and we kind of did something like this yesterday. So once it's factored and it equals 0, that means that one of these must be equal to 0. So we'll set them each equal to 0. All right, and then we're going to solve them down. So cotangent of x equals 0, we're good. The cosine squared one, we have a couple of steps. And we don't have a hand trick or the unit circle for cotangent. So what I would do is if I know the cotangent of x is 0, the tangent of x is going to be the reciprocal of that. So what is the reciprocal of 0? Undefined. Good. Okay. And then tangent is only undefined on the unit circle. So I shouldn't say that, on the quadrants. So we're going to go to our unit circle, wherever it is. Okay. And for tangent to be undefined, the x-coordinate would need to be 0. Because we would be dividing by 0. So where is tangent undefined? Which angles? There you go. Pi over 2 and 3 pi over 2. So from that equation, we're going to get x is pi over 2 and 3 pi over 2. That's where tangent of x is undefined. Now, do you guys know what the square root of 2 is about? 1.4 something. So can the cosine ever equal 1.4 something? What is the largest value you can get when you take the cosine or sine of an angle? Do I remember? It's 1. So when you take the sine or cosine, you're always going to get something between -1 and 1. So this is not possible. Because the range of sine and cosine is from -1 to 1. So it's always going to give us a value between -1 and 1. And you could try to do it, like if you're trying to do the hand trick and this would be, it would be really hard because it would be somehow when you do the top fingers over 2, you get the square root of 2, and you could try all your fingers and it's never going to happen. All right, any questions? And that's fine. That happens a lot, actually. One side of your equation won't even work, and you just get your answers from the other side. Okay.
So you've got the coordinates.
These aren't coordinates. This is an interval from -1 to 1. So this is the range of the sine and cosine. So that always gives us something between -1 and 1. Now tangent and cotangent can be anything when you take them. Any real number, I should say. Okay, let's look at another one. Let's look at B. For B, we have 2 cosine squared of x minus 5 cosine of x plus 2 equals 0. All right, so when you guys see ones like this, I hope that you think of like trinomials. Like when you first learned how to factor, that's what we're going to do. It's going to be kind of weird because you have cosine in there, but same idea. All right, so what we put here and here is going to need to multiply to give us 2 cosine squared of x. So that's going to be 2 cosine of x and cosine of x. What do we know about our sines? They're the same, and they're both negative. Okay, and the only way to get 2 is going to be 2 and 1. So we have to figure out where to put the 2 and where to put the 1. I know I can't put the 2 here because it has a common factor with that 2. So the only way this could possibly work out is if the 2 was with the cosine and then the 1 was with the 2 cosine. And it does work. When we multiply here, we get -4 cosine of x minus 1 cosine of x gives you your -5 cosine of x. Okay. So now, just like the previous problem, we're going to set each of these equal to 0 and solve it from there. Okay, so we want an angle that is going to have a cosine of 1/2. So if you're using the hand trick, remember cosine is the square root of the top fingers over 2. So we want 1 top finger. So what angle is that going to be? Pi over 3. Where else is cosine going to be positive? Quadrant 4. And so what's pi over 3 in quadrant 4? 5 pi over 3. Nice job. All right, now can we take the cosine of an angle and get 2? No, it's too big. So this one is not possible. And that's fine. Our two answers are pi over 3 and 5 pi over 3. Okay, now the last two that we're going to use, we're going to use a couple of identities. So for C, we have cotangent squared of x plus cosecant squared of x minus 7 equals 0. Now there's a little bit of a problem with this one because we have two different trig functions. We can't factor it the way it's written now. So we can either change cotangent squared to something with cosecant, or we can change cosecant squared to something with cotangent. And it should work out the same either way. But I know that, I think it's number 11 on your sheet, tells you that 1 plus cotangent squared of x is cosecant squared of x. So I would just use that one, since you wouldn't have to manipulate it anyway. Just use it just like it looks. That's what I would do, but it would work out if you did it another way too. All right, then I would just bring everything else down in the equation. From there, I'm going to just combine my like terms. So I would combine my cotangent squares by adding them together and combine 1 minus 7. All right. At this point, this is kind of like where we started yesterday, where we would just solve this down to cotangent of x by using algebra. And then, because I want to use the hand trick in a second, I don't want cotangent, I want tangent. So tangent should be equal to the reciprocal. Now for tangent, you need to have it not in simplified form to do the hand trick. I said that really weird, I'm sorry, but leaving it like this is going to help us do the hand trick. If we simplified this, it would mess us up. So that means we want 1 bottom finger and 3 top fingers. So what do y'all think? Pi over 6. All right, what quadrants are we talking about here? All of them. All right, so we need pi over 6 in every quadrant. There it is. All right, we have one more, and I'm not gonna lie, it's pretty challenging, and you have to do something on here that without someone telling you to do it, it's not something that you just kind of think about doing. All right, so for D, we have tangent of x minus secant of x equals 1. So when you see tangent and secant together, you probably think about that Pythagorean identity that has both of them in it. The problem is, in that identity, they're both squared. And we cannot use that identity without a tangent squared or without a secant squared. So what we're going to do is actually square both sides of this equation, and then we can have tangent squared and secant squared. But before we do that, it's easier for us to square both sides, and it works out better if we separate the trig function. So have 1 on each side. And again, this is not something we've done before. So this is kind of a new idea. So the easier one to move would be the secant because it's already negative. So you can write that secant of x plus 1 or 1 plus secant of x. It doesn't matter for adding. All right, and so I do want to use that Pythagorean identity. So I'm going to square both sides. Okay, so that's going to give us tangent squared of x. Now when I square a binomial, I can use that shortcut for squaring binomials, or I can multiply it by itself. I'm going to use the shortcut where I square the first one, multiply them together and multiply by 2, and square the second one. Okay, so now we're in a similar situation to what we had with C. The difference was with C, we could change either one. This one, there's only one way to make it work from here to the end. So do you guys think we need to have just tangents or just secants? Yes, just secants, because this secant I'm not going to be able to get rid of. So what I would do is go ahead and use my identity, I think it's number 10, to change tangent squared. What is it? What did we? Good job. Secant squared of x minus 1. And we have to manipulate it a little bit, but it all works out. Okay. So now I would go ahead and get my secant squareds together. And something kind of nice happens. When I get those together, they actually subtract away. So I don't have a squared anymore, which definitely makes this an easier problem to solve, because you're not going to have to factor it, which is nice. Okay, so then I would go ahead and move my 1 over and divide by 2. So if I know the secant of x is negative 1, what is the cosine of x? Also negative 1. All right, so if I have sine or cosine equal to negative 1, where do I go for that? Unit circle, good job. All right, so I'm looking on that unit circle for an x coordinate to be negative 1. There it is. What do y'all think? Which one has the x coordinate of negative 1? Pi. There we go. We're not done with this problem. Hang in there. So whenever you have to square both sides to solve an equation, sometimes it creates an extraneous solution. And we talked about this when we were doing radical equations. You'd have to square both sides. You always had to check your answers. Same thing on trigonometric equations. So squaring both sides can create extraneous solutions. So we just need to check our answer. And checking the answer doesn't take anywhere close to as long as working it. So we just go back to the original equation and we're going to plug pi in for x. All right, so we need to know the tangent of pi and we need to know the secant of pi. All right, so tangent, we're gonna do y divided by x. So if we go to pi, what should the tangent of pi be? 0. All right, and then for secant, it's gonna be the reciprocal of a cosine. So for cosine, we're just gonna look at the x coordinate. What is it? At pi? -1. And the reciprocal of -1 is -1. And 0 minus -1 is 1. So we're good. That it all works out. If it was extraneous, you'd get something like 1 equals -1 or something weird. Or something undefined. It works. Now, one good thing about our challenge exam is it is all multiple choice. So if there's a problem like this and you just get hung up and you cannot remember what to do, you can plug in the answer choices. And if you have all of this stuff memorized that I have up here, then you can plug in the answer choices pretty quickly and know which answers work. So don't forget about that.